Hi, in this video I'm going to show you uh, how to write a program to predict stock value using TensorFlow. Uh, so in this video I'm going to show you how to get the Yahoo online up-to-date stock data, okay, for time series data analysis. The TensorFlow is configured to a specialized recurrent neural network called long short-term memory (LSTM). And RNN is a type of neural network well suited to time series analysis. RNNs process a time series step by step, maintaining an internal state, summarize the information they have seen so far. So it's very efficient, to this type of prediction or forecasting. Okay. So first, let's run this block to see if the Google Cloud is ready for the program. Okay, it's running. So again, my name is Dan Low. So the first time to run the program, you will need to install the Y Finance module and the Yahoo Earnings calendar by running the following commands. After that, you can comment it now, so you don't need to run that again. Okay, but every time, the first time you try to run the program from the Colab, Google Colab, you will have to install it. So this is a one-time deal every time, but it's okay because Google Cloud is free. So after that, then you can import the module we need. Here we use the Y Finance and Yahoo Earnings calendar, okay, and the Pandas Nambi, okay. So just import them in, okay. So after the this piece of code I wrote is to be able to create a drop-down box to select a specific stock you want to analyze. Okay, so we manage to get the Yahoo Earnings calendar, and then that will give you a report. In that report, there are some tickers. Okay, so we want that tickers. Actually, not tickers. Uh, so we want that ticker so that we can retrieve data. So they just run it. Okay. So and the reason we need to get this Yahoo Audience calendar, to get the ticker symbol, is because the Y Finance, Yahoo Y Finance does not provide the list of all the tickers. Okay, but anyway, you can easily Google search the stock ticker you want to analyze. So the next thing is we're gonna use some time module, okay, to get the day. And the day here I set it to the May 22nd, 2020. You may set it to some other day to have more information on it. So we go ahead and run it. Okay. So after we run that, then in this piece of code, uh, we are going to create a drop down box to select the stock you want to analyze it. So basically I use this IPywidgets, okay, and the module is drop down, okay. So use that so that I can start creating the options from the Yahoo early earnings table, okay. Then display it. Then finally the value will be selected and set it to a variable ticker. So if I go ahead and run it, as you can see that you can see there's something for you to analyze. And I'm just going to use the first one, Alibaba. Okay, so Alibaba got selected. Okay, so after that, I can move down to here. So here I can get the Alibaba stock information from the Yahoo Finance. Okay, and here you just put the ticker, which you put the Baba, Alibaba, and start day and day. Okay, so you go ahead, run this. Okay, so you got the data retrieved from Yahoo Finance. Yahoo Finance is the only place I found that provides free. You don't need to register uh, stock data for analysis, and it's up to date. Okay, then let's take a look at the data first. So the data, you can see you got 1 2 3 4 some columns, 6 columns, and then there's a date, the index, and then the open, high, adjust, close, and volume. So we got the data. Okay, so as of the today, May 20, I said in May 22nd, so May 21st, the cost value is like to 12 per share, and we want to know all the columns. So we go ahead just show all the columns we have. So we have the column open, high, low, close, adjust, close, volume. Okay, so I'm going to use the adjusted close. Okay, the value adjusted. Okay, not a cost value because the company may do some operations, and then the value may change. So I use the adjust close column for our data. So simply just size out the adjusted close column for our study. So we can just go ahead using the data sub adjust close. Okay, and then also assign the data index, which is the time or the date to the index, and I put everything into y, and also plot it to take a look at the data. So the data we collected now is like since 2019 all the way to about yesterday. Okay, so it's about this. Altogether they're going up. The trend. Okay, now we're gonna convert the pandas series to NumPy n dimensional array for the processing. So you can simply say y dot values. Okay, and assign that to y. Okay, so you override it. So now y's data type is the n dimensional array. Okay, and next step we're going to do is split the data into training and testing, and that's a typical data analysis step. Okay, so we use the 80-20. 80% of the data is used for the training and 20% used for testing. Okay, so the training size is the size of the total data we have, entry we have times 0.8, and then we go and print it out. We have about 280 data points for the training. Okay, and after that we normalize the data. That's also a typical way to data preprocessing. Okay, so we normalize the data using the training data sets mean and standard deviation. Okay, so the y is the n dimensional array now, and then its dimension is 1. Okay, so the training we just slice out the whatever the y value up to the training size. Okay, so the y sub column training size will take that, and that mean will get a mean. That's a training data mean. Okay, then we put it into a variable training mean, and training standard deviation. You can do similar things. Okay, and then after that we use that training data mean and standard deviation to normalize the data using the y minus training mean divided by training standard deviation. Okay, so that will normalize our data. Okay, And next, we're going to okay, so run it. Okay, next we're gonna take a look at the data, the first 6 0 to 5 to see what it looked like. So it looked like this. Okay, -2, -2.5, -2.06, and so forth. Okay, and now that's the data being normalized. Okay, and next we're gonna define a function to prepare the data. Okay, so this is the key step in the LSTM analysis. So the time series data are organized to form feature vectors and target values. So the basic idea is we want to create the feature vector and the target value out of the time series data. So for example, if the history, the end history, we set it 10, that means you want to look back 10 data points for the current point. Okay, so the history 10 data points, okay, will be the feature vector of the current data point to be predicted. Okay, so that is the basic idea. So this function data preprocessing basically try to split the data, prepare data in a way that it spit out the feature vectors, okay, and the target values based on the the size of history, how many data points you want to look back from at specific time point. Okay, so after that you should get a two set of data returned. The first set is the feature vectors, and the second set is the target value you want to predict. Okay, so that's the function we defined, and we're going to use this data. So I'm going to go ahead and run it. Okay, so after we define the data preprocessing function, now we can define the history data. Now we're going to use just 10 history points for the feature vector, to predict the target. So we just go ahead call the data preprocessing function we defined earlier, and then pass it to the data set we have, and then also pass to the training size. Okay, and then I'm gonna split the y train and x train. So x train gonna be the feature vectors, okay, and y train is the target value. And similarly, we get another 20% of the data into the cross validation or testing data. Okay, we do the same thing, so we got x test and y test. Okay, so we can go ahead and run it, and now we can take a look at the x test 0. Okay, so x test 0, as you can see that it contains the feature vector with 10 elements. That's what we said. Okay, and then if you see the x test vector 1, then compare the two, you'll find that the x test sub 1 start with the second element of x test sub 0, 2.12, because we shift the window 10, from 0, 1, 2 all the way up. Okay, so now we can get the TensorFlow in and define our LSTM model. Okay, so this is very typical. One thing I want to point out, I set the random seed to be a number, so that all the experiments you can reproduce. Okay, if you don't set that, then every time you run it, you get different results. So it's hard to trace whether is the program's not working or something wrong. So set this will ensure the reproducibility of the program. So go ahead and run it. So after we set the model, then we take a look at the model summary. So you see that there's a LSTM there, okay, with n nodes, okay, and the total parameters is 329. Okay, so now we need to compile the model by setting some hyperparameters, such as optimizer. We use Adam optimizer, and loss function we use the MSE. Okay, so we go ahead run it. Now the next thing is we want to shuffle the data around. Okay, using the provided data preprocessing function data set. Okay, so we do the same thing for the test. Okay, as we do for the training data. Okay, so this basically shuffle the data around and ready for the TensorFlow to run. Okay, so after that, then we get to the model will be ready for training. So here we set the abacus to 10, and each abacus we set 200 steps iterations, and again we pass the validation data is a p-test, and the training data is the p-train. Okay, then the validation steps is 50. So this is gonna take a while. So let's go ahead and run it. Yeah, it's running on the Google Cloud, so it should be not too slow. Okay, depends on the load of the server. So we done training. I just for testing. Okay, if you want to get a better result, you can play around with these numbers. Okay, with these numbers abacus and the steps for abacus and all that. Okay, also you can play the buffer size, batch size around. Okay, so after that we're gonna take a look at the loads during the training. Okay, so we got loads and val loads. Okay, so here the loads is basically the values of the cost function for the training data. The val loads is the value of the cost function for cross-validating data. So let's go ahead and take a look at the loads function. Okay, so you can see the orange line is the val loads, which is the value of the cost function for cross-validation, and the loads for the cost function for the training list is lower than this. It's because this is the this represent the reality. Okay, let me just put it this way, because the training is based on the training data, but cost validation, try to see how good the model is trained. Okay, so it's a little bit higher, and that's typical. Now let's run the next one. We're gonna predict stock values after the model is trained. So we can, and we keep the predicted values and target values for graphics, to plot it later. So you can change the p trend, to p test, and then see what happens. So let's now first run the p trend. Okay. So after run that, so we have the trend, we have the predicted value for the trend data. Okay, then we can plot it. Okay, so here you can see the orange line is the target value we want to predict, and the blue line is the predicted value. Okay, but this is the trend data. Okay, so if you change this to, if you change the trend data to test data. Okay, here you can take trend data to test data, because test is supposed to be something the model never seen before. Okay, so this is the close to reality if you want to predict the stock value, and the predicted value is in the blue line. The origin line is the target, so you can see it. It's very close, basically. Okay, so if you want to get closer, okay, more accurate, then you can play with the numbers, run more iterations. So that's all I have for this video. So thank you for watching, and please subscribe, thumb up, and share. If you'd like to watch something else, please keep a comment in the video. And again, I'll provide the Google Colab links, for you to play around. So once you got the link, you can click on it, and you can run it, make a copy, or run it in the I think there's a mode for you to run. Okay, so that's all I have. Thank you.